All right, welcome to The Explainer. Today, we've got a real cosmic detective story on our hands. There's this object, 3I/Atlas, visiting us from another star system. It's zipping through our solar system, but something's pushing it, something that isn't gravity. And that, right there, is where the mystery begins. So here's our game plan for cracking this thing open. First, we'll look at that weird acceleration. Then, we'll check out the number one suspect, the good old comet theory, and why there's a huge hole in that idea. After that, we'll dig into even more strange clues, and finally, figure out what scientists are going to do next to get some answers. Okay, so let's start with the absolute heart of the puzzle. We've got this visitor, 3I/Atlas, and it's being pushed by some kind of mysterious force. The crazy part? We can measure the push. We know it's there, but we can't see what's causing it. You know, we're actually really good at this stuff. Scientists can predict the path of a space object with incredible accuracy just using the sun's gravity. It's just physics. But this one, 3I/Atlas, it's veering off that path. It's like throwing a baseball and watching it just curve in midair for no reason. So the billion-dollar question is, what is giving it that push? And get this isn't some tiny little nudge. In just 1 month, this mysterious push has shoved the object 80,000 kilometers off course. I mean, that is not a rounding error. That's a huge, huge deviation, and it's screaming to scientists that some kind of powerful, nonstop force is at play here. Now, what's wild is that the force itself is actually tiny. We're talking a fraction of a millimeter per second squared. But here's the thing about space. It's big, and things travel for a long time. So you apply that little constant push over millions and millions of kilometers, and boom, that's how you get an 80,000 kilometer drift. And to make things even more complicated, this push isn't just a straight line. Nope, it's actually got two parts. There's one force pushing it directly away from the sun, and another one pushing it sideways. This just makes everything way trickier to explain with one simple answer. All right, so let's get into the most obvious explanation, right? When astronomers see something getting pushed around in a way gravity can't account for, their minds immediately go to one place. The prime suspect is always the same. It's got to be a comet. See, with comets, this kind of weird movement is totally normal. It's textbook, really. As a comet gets closer to the sun, all that ice on its surface heats up and basically boils off into space. It shoots out these jets of gas and dust, and those jets act like tiny little rocket engines, pushing the comet around. The official term for it is outgassing. So yeah, that's the easiest way to think about what everyone first assumed was going on with 3I/Atlas. It's not just coasting on gravity's path. It's got these little natural rockets firing, pushing it off course. Simple enough. Case closed, right? Well, not so fast. And this is where the story gets really interesting. Because when the astronomers sat down to actually run the numbers on this whole outgassing idea, that nice, simple, natural explanation, it just completely fell apart. Okay, so the biggest issue is the sheer size of this thing. We are not talking about some small piece of space rock here. Its minimum estimated mass is 33 billion tons. That could be up to 1,000,000 times more massive than that other famous interstellar visitor, Oumuamua. This thing is an absolute beast. And because it's so ridiculously massive, you need a ton of force to push it. So the scientists did the math. To create the acceleration they were seeing, 3I/Atlas would need to be blasting out a staggering 5.5 billion tons of gas and dust. Just think about that number for a second. That's about a sixth of its entire weight. If it were actually throwing off that much stuff, it would create this massive, incredibly bright cloud of gas and dust. You know, a classic comet tail. It would be so big and so bright that there's no way our telescopes would miss it. And yet, what do we see? Nothing. Zip. Zilch. No tail, no cloud, no dust. We just see the push. And believe it or not, the problems for the comet theory don't even stop there. As astronomers kept looking closer, they found two more clues that make this whole thing even stranger and make that simple, natural explanation look even more shaky. So first up, its brightness. It's getting brighter way, way faster than any normal comet we have ever seen. And second, its color is just wrong. Cold, dusty, icy things out in deep space, they should look reddish. But 3I/Atlas, It's blue, really blue. Just to put that into perspective for you, take a look at this. On the one hand, you have the rate a normal comet brightens as it gets near the sun, and then you have 3I/Atlas. It is not even in the same ballpark. It's brightening at a rate that is completely, totally off the charts compared to literally any comet we have ever studied. So let's recap. It's not behaving like a comet. And the math for it being a comet just doesn't add up. So what on earth is the real story here? And how do we even begin to solve this? You know, there's a great quote from the Harvard astronomer Avi Loeb that really hits the nail on the head here. He says, "You don't get to say the data is wrong just because you don't have a theory that fits it." And that's exactly the point. This isn't about jumping to crazy conclusions. It's about the number one rule in science. You have to follow the data, especially when it points to something that completely shatters what you thought you knew. And that is exactly what they're going to do. There's a key window coming up between late 2025 and early 2026. And during that time, the world's most powerful eyes, we're talking the Hubble Space Telescope, the James Webb Space Telescope, they're all going to be pointed right at 3I/Atlas. And they'll be looking for one thing and one thing only. Where is that giant missing cloud of gas? Now, if they find that gas, hey, mystery solved. It's just a really, really weird comet. And that's cool too. But what if that window comes and goes and our best telescopes in the world still see nothing? Well, then the most obvious, most natural explanation completely fails. And at that point, science is forced to look a profound mystery right in the face, leaving all of us to ask, what else is out there? Traveling through our solar system, pushing itself silently through the dark.